Okay, so now I want to tell you about some basic properties that logarithms satisfy. So you can actually simplify things with logarithms in them and sort of do all sorts of functional sort of fondling with logarithms just by knowing some basic properties. Now, all these basic properties, in fact, have analogs to sort of exponentiation. And that's not that surprising when you think about it, because remember that a log is an exponent. So basically, facts that we knew about exponents in olden days should have analogs, at least some form of analogs, in this new setting. So what I want to do is try to, first of all, give you some sort of foreshadowing and remind you about how the properties looked with exponents, and then see the analog there. Okay, so here we go. First of all, if you have b to the m and multiply that by b to the n, then if the bases are the same, what we can do is add the exponents. Now, this is just a recap of stuff with exponents. Similarly, if you have b to the m and you divide it by b to the n, then in fact there we have b and then we subtract m minus n. Okay, so these are, for example, two properties that we know about exponents. Let me show you now the analogs to logarithms. So the analogs in the logarithm case would be the following. This would say, well, if you look at the logarithm that you would get if you take a product of two things, that logarithm would be the sum of the logarithms. So the conversion of this fact to logs would look like this. Log base b of x times y, the exponent of a product is the sum of the individual exponents. So this should be log base b of x plus log base b of y. So this is actually the analog of this in some sense, right? Because this says if you're taking the product, the exponent on the product, you add the exponents. This is saying if you take the exponent of the product, you add the exponents. So here's the rule. But forget about where it came from. Now look at the rule. Log base b of a product is the sum of the logs. So whenever you see log of a product, you can write that as sum of logs. This thing can be converted in the following way. If you look at the exponent of a quotient, that will be the difference of the exponents. So that would be log base b of x minus log base b of y. So here are two log facts that actually come quite naturally from these two exponentiation facts. So if you have log base b of a quotient, that's the difference of the logarithms. Okay, let's take a look at some more facts and start making a list of some log properties that we can use. First of all, let's start off with some really, really basic ones. Log base b of b. What would that equal? Well, that's the exponent that I have to raise b to in order to make it equal b. Well, that exponent is 1. So log base b of b is always 1. Always 1. Why? Because log is the exponent. 1 is the exponent I have to raise b to in order to get b. Not a problem. Another really, really easy one is the fact that log base b of 1 equals something that always is easy to figure out. What exponent do I have to raise b to in order to make it equal 1? b to what power equals 1? The answer always is 0. So those are two facts that are always true. Log base b of b is 1. Log base b of 1 is 0. Don't memorize them. Think about what they mean. Log is an exponent. b to the 0 equals 1. Okay, so there's two facts. Let me now record the other facts that I just showed you. Log base b of x times y equals log base b of x plus log base b of y. Okay, and then there was that quotient one. Log base b of a quotient, x divided by y, equals log base b of x minus log base b of y. And notice, by the way, how the subtraction goes. The thing that's in the denominator is what I'm subtracting. You can't just flip these things, right? Log of x over y is log of x minus log of y. So you have to be careful how the subtraction goes. You're subtracting the bottom part. Okay, and there's one other fact that's really handy, and that's log base b of x to the y power equals y times log a base b of x. So there's a really important formula. Log base b of x to the y power equals y times log base b of x. And so what that's saying is if you have a little exponent inside this thing, you can take that exponent and pull it way out in front right to here. Where does this come from, by the way? You might say, well, gee, where does that come from in terms of the exponentiation facts? Well, it turns out that comes from the following. I'll just remind you of this really fast. If I have b to the m and I raise the whole thing to the n power, what do? Well, if you take something and exponentiate that whole thing, you take the product of the exponents. So this is b m n. And that's exactly what's going on here if you think about it. If you look at the exponent that we would have on something with an exponent, that exponent is the exponent multiplied by the previous exponent. So in fact, these two things really are sort of saying the same thing, but they look a lot different. The bottom line is that log base b of x to the y equals y log base b of x. You can pull this out in front. That's the law. That's the law. Okay, those are the fundamental properties. Those are the ones we're going to use. Before I go on and start showing you how to use them, I want to show you two really, really popular wrong formulas. These are formulas that people love to use despite the fact they are false. So the first wrong formula is the following. This is a classic, by the way. This is an absolute classic. Log of x plus y equals log of x plus log of y. People love that one. Log of a sum is the sum of the logs. Okay? This, in fact, is a classic. In fact, this makes it on my top 10 list of classic mistakes. This is number 9.
The log of the sum ain't the sum of the log. Number 9.
Number 9.
Number 9.
The log mistake. Always remember, the log of a sum is not the sum of the logs. This is false. This is false. The log of a product is the sum of the logs. The log of a sum has no standard formula in general. So please don't make this classic mistake. In fact, number 9 on my list of top 10. Classic mistake. So there's a false formula. Another false formula in sort of the same direction is the following. This is a great one. People love this one. And they use it all the time. That's what's sad. It's okay to love something that's not true, but it's always bad to use something that's not true. Log of x over log of y, people say, oh, it's the difference. So it's log of x minus log of y. You see, those people are sort of close, right? Those are sort of close. Because they say, well, quotient, that means difference. That's not how the formula goes. Take a look how the formula goes. It's the log of a quotient is the difference of the logs. This is the quotient of two logarithms. You see the difference? This is log of something over something. This is log something divided by log something. Those are two things and they're not the same. So in fact, this formula is blatantly false in general, and in fact is not true, whereas the actual formula, what this thing actually equals here on the bottom, is precisely the log of the quotient, not a quotient of the logs. So two really, really popular classic mistakes for logarithmic formulas that a lot of people will make, and even after they see it, they still may make it. So if you make that mistake, don't worry too much, but really try to focus and not do that. And remember, these 1, 2, 3, 4, 5 basic formulas, they will get you through any log jam, as you'll see coming up next.